So first, we have Carl Fossum from Chemistry and Physics at UW-Eau, winner of the Campus Science and Technology category, presenting on understanding the severity of COVID-19, a point of view through the lens of a computational chemist. Thank you. You may begin.
3.5 million deaths globally. COVID has changed our lives forever, and the end still isn't in sight. Hi there, I'm Carl Fossum. I'm a senior at the University of Wisconsin-Eau Claire, and I'm majoring in chemistry and physics. Today, I'd like to have a short conversation about COVID-19. So far, multiple companies have developed vaccines within the last year, and we've used these to help combat the spread of COVID-19. That's fantastic. That's great. I'm really happy that we're at that point. However, the rapid spread of COVID-19 throughout the globe has caused new variants to show up all over the place. We see this here in the US, over in Asia, Europe, Africa, South America, and in Australia. So because of this, it's not guaranteed that current vaccines that we have will always be effective at combating COVID-19. Likewise, as we've seen everywhere, vaccine rollouts have been lackluster and billions of people are still unprotected from COVID-19. Therefore, it's important that we as scientists, as human beings, research other long-term therapeutics for treating severe cases of COVID-19. But first, let's talk about some context here. In nature, our bodies naturally fight against viral infection. We've all gotten the flu before. We've all, been sick for a couple of days, but we've recovered. One way to quantify our ability to do this is through the study of something called internal oxidative stress. You could think of oxidative stress as how well your body deals with volatile or toxic compounds. When we're young, our bodies have very low oxidative stress. We get sick, we go home for a day for school, we're back and we're good to go. But as we age, our oxidative stress levels increase for various reasons. You have a night shift job, you're in school, whatever the case, you're more stressed out and you're more susceptible to being sick. The goal of our project is to study oxidative stress and say, hey, how does that relate to infection of COVID-19 and its severity? To do this, we've used some high-powered supercomputers to simulate the virus infecting the host cell. We did this using a robust and standard method set by the scientific community known as a molecular dynamics simulation. Initial results from these simulations indicate that a reduction in oxidative stress significantly reduces the ability for COVID-19 to bind to its receptor in your body and to make you sick. In the long run, this means that, okay, if you have lower oxidative stress, you still might get sick, but it's less likely for it to kill you, for COVID-19 to kill you. And these results aren't our own. Recently, researchers from an Institute of Chemistry in Slovenia verified our theoretical findings in a laboratory study published just a couple of weeks ago in FASAB, a major biochemistry journal. We believe that bridging the gap between the people that are vaccinated and those who are not vaccinated is critical in eradicating COVID-19. So you might be asking yourself, okay, cool, but how can I help myself reduce oxidative stress? Well, natural antioxidants such as vitamin D, vitamin C, and yogurt are great for reducing oxidative stress. Likewise, getting daily exercise and being active is another good way you can reduce your oxidative stress. However, there's more than just that. Our group's published research in this topic has been cited in clinical trials for a new drug known as butylamine that is currently pending FDA emergency approval for treating severe cases of COVID-19. We believe that this drug and others are excellent candidates for a global vaccine rollout alongside existing programs. Together, we can stop the virus, we can heal the economy, and we can prevent thousands of more unnecessary deaths from COVID-19. Thank you.
Thank you, Carl. Okay, judges, please turn on your video. Do we have any questions for Carl?
I just had a quick question. So Carl, this kind of gets into why children are less impacted by COVID, it sounds like.
Yeah, exactly.
Huh.
It's a
Cool.
Yeah, it's a broad, the idea of looking at oxidative stress isn't necessarily new, and not just our lab, but hundreds of labs around the world over the last year have been looking into this way for studying disease, whether it be COVID-19 or any other disease. And so you're right on that this is one way, a lens, a point of view perhaps on why children are less susceptible to severe cases of COVID.
Okay.
So Carl, this was really informative. And I guess as you are going down this therapeutic line of thinking and addressing COVID, how do you see that holistically working with vaccines, for example, knowing that they're kind of two courses of action in how we tackle COVID?
Yeah, absolutely. And please don't get me wrong. This is not something to replace vaccination. Vaccination will always be the number one thing you can do to prevent any sort of disease from spreading through a community. Our idea here is, there are groups of people who are not going to have access to the vaccine. We've already seen this in the US and other places around the world. So if we can have, whether it be a medication or some sort of activities you can do to reduce your oxidative stress that anybody can do, that will help kind of bring in the equity of vaccine, of treatments for COVID-19, and help herd immunity kind of spread at a more equal rate rather than just the people who have access to a vaccine.